Okay. So we just started recording. Let's go over the homework. Let's see if I'll just wait till Jason rejoins. I'll start sharing. I'll be very confused if he doesn't rejoin. Oh, he is here. Wait, Colin, can you see this participants tab on the screen? Can you, Colin?
What?
Can you see the participants tab?
No.
Oh, okay, that's cool.
It's a button that's that button, and if you're on like mobile, it should be on the top.
What?
I was just telling him where the participants tab is.
No, I know where that is. I was just asking if you can see it while I was sharing screen. Okay, so let's start the homework. There's a list of 200 random numbers with 3 and 5 being the first two numbers. The total sum is 2,000. If the 3 is replaced with a 5 and the 5 is replaced with a 7, what would the sum be after the number replacements? Okay, so I'll just do this problem. So you have a list of 200 random numbers, and as I said in the last class, that if you have a list or something set up and the question never specifies what the other numbers in the list have to be, you can assume they can be anything. So you can fill them in with zeros or random numbers as long as they satisfy what the problem is looking for. So you have a list of 200 random numbers with 3 and 5 being the first, so we can just 3, 2, 3, 5, and then we can have 192, and then the rest are all 0. That's a possible list. So we'll just stick with that list. If the 3 is replaced over 5 and the 5 is replaced over 7, you have 5, 7, 192, and then 197 zeros. So if we just add these up, we have 5 plus 7 plus 192 is equal... Oh, let me edit this. It's not 192, it should be 1992. What? Where's the 1992? Okay. 0, 0, 0, dot. So now you have this list and you just add them back up. 5 plus 7 plus 1992 is equal to 2004. So for problem 1, 2004 would be our answer. Okay, so problem 2, Leo has a stick made of 64 building blocks. He splits the stick in a way such that one part is 3 times as long as the other. He then repeats this for all pieces as many times as he wants. What lengths could the pieces have? Okay, so he splits the stick into a way such that one part is 3 times as long as the other. We can just make a pyramid with 64 being the starting, and then we have, it breaks into 2 sticks. So one is 3 times as long as the other, so you would have 48 and 16. So one is 48 blocks long, and one is 16 blocks long. And then we keep on doing that. 48 splits to 36, 12, and 16 splits to 12, and 4. And then we keep splitting. 36 goes into 27, 9, and 12 goes to 9, 9, 3, 12 goes to 9 and 3 again, and 4 goes into 3 and 1. And 27 cannot be split further, so the numbers we have are 1, 3, 4, 1, 3, 4, 9, 12, 16, 27, 36, 48, and 64. And that would be our answer for problem 2. Let's go to problem 3. 3 pencils have the same weight as 2 erasers on a scale. 2 erasers, and on a scale, when a pencil and eraser are put on a scale, the weight is 10 pounds. What is the weight of a pencil? So we have 3 pencils with the same weight as 2 erasers. So we can also say that one eraser is the weight of 3/2 pencils. So you have 1.5 pencils that is equal to the weight of an eraser. When they are put on a scale, the weight is 10 pounds. So when you have 3/2 pencils plus 1 pencil equals 10 pounds. Then you have 5/2 pencils is equal to 10 pounds. And then if you solve this, you get 1 pencil is equal to 4 pounds. And that's all you need for homework problem 3. Problem 4, Jerry's chickens have 9 more legs than heads. How many chickens does he have? Okay, so if he has the chickens, one chicken has 1 more leg than a head, because chickens have 2 legs and 1 head. So one chicken has 1 more leg than head. More leg than head for 1 chicken. And if you have 2 chickens, that is 2 heads total and 4 legs total. So 2 chickens is equal to 2 more legs than heads. So the pattern emerges that the number of legs more than heads is equal to the number of chickens total. So if you have 9 more legs than heads, then you have 9 chickens total, which is the answer for problem 4. Okay, so now that we're done with the homework problems, let's go on to the questions. So 24 of Math Kangaroo 2017, 3 to 4th grade. Problem 24. Leonie has hidden a smiley behind some of the gray boxes. Numbers state how many smileys there are in the neighboring boxes. 2 boxes are neighboring if they have 1 or more corner in common. How many smileys has Leonie hidden? Okay. So we'll just put down check marks for where the things could be. Let's start with these 2 twos over here. We know that if a box is next to another, if they're diagonal or adjacent, which means they share a side, then if there's a smiley behind one of the boxes, that means that there would be 1 here. If there's 2 smileys close to it, then there's a 2 here. And here, if there's 3 smileys, then there's a 3 here. Okay, so let's first look at how we could arrange the smileys to fit this 3. If you have, I'll just put check marks for the smileys. If you have it like, if you have them in an arrangement like this, that means that this 2 here would have 3 check marks next to it. So that can't be possible. We could erase one of these check marks, and we could replace a check mark over here, so the 3 would still be satisfied, and the 2 here would be satisfied. And then what else we could do is we could put a check mark here. So this 2 is satisfied, and this 2 is also satisfied. All of these boxes are satisfied except for this one down here. And for this one, we have 4 spots that we can put the check mark in: here, 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 and here. And the only one that wouldn't disrupt any other boxes is here. So this is how we would put the check marks. And we can count how many check marks there are for how many smileys that are hidden. 1, 2, 3, 4, 5. So your answer for 24 would be B. Okay, so on to question 24. So now we're on question 23. Kate has 4 flowers, each of which have 6, 7, 8, and 11 petals. Also, for 24, the best strategy to solve these problems would just be to guess, but don't randomly guess. See what you can guess and figure out the correct guesses, and you can solve the problem from there. This is also true for a lot of the problems in Math Kangaroo. For problem 23, Kate has 4 flowers, which have 6, 7, 8, and 11 petals. She now tears off 1 petal from each of the 3 flowers, then repeats this until it is no longer possible to tear off 1 petal from each of 3 different flowers. What is the minimum amount of petals left over? Okay, so let's see how we can do this. We can we can put X's over the petals that have been torn off. So here's the first ones. We can take these 3 off. Then we can take these 3 off. 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then we have some more petals that we can take off. So 1, 2, 3. And that's where we stop. So we have 1 over here and we have 10 here. So we have 11. 11 isn't any of the choices here, so we can obviously do better. Let's try again. So we have 1 here, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And we just keep doing this until we have a good answer to this problem. Okay, so now we stop. We have filled in as many as we can, and here on the 6 petaled flower we have 3 left. On the 11 petaled flower we have 2 left. And these 3 over here we have none left. So the answer for problem 23 would be 2 plus 3. 2 plus 3, which is equal to 5. So your answer for 23 would be E. This one you don't need much guessing, but you just have to fill them out in the right way. And don't immediately stop, and also check what you got to the answers to make sure that you don't waste any time by redoing it and getting the wrong answer. Okay, so on to problem 22. A small zoo has a giraffe, an elephant, a lion, and a turtle. Susie wants to visit exactly 2 of the animals today, but does not want to start with a lion. How many different possibilities does she have to visit the 2 animals, one after the other? So we'll just write down all the possibilities. This one is very easy. And we cannot start with a lion, so we have 3 to start with. We can start with G for giraffe, E for elephant, and T for turtle. And then the second one we can do all of them. So G for giraffe, E for elephant, L for lion, and T for turtle. Let's just write down all the possibilities. And you cannot visit any twice. So you cannot have GG or EE or TT. So GE. And we just write here. Now I just write down all the possibilities. GL, GT, G, EL, ET, TG, TE, TL. So now we count out all the things that we got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and the answer for problem 22 is D, which is 9. This is pretty easy. Shouldn't give you any trouble. Now for problem 21. 5 boys share 10 bags of marbles between themselves. Everyone gets exactly 2 bags. Alex gets 5, Bob 7, Charles 9, and Dennis 15. Eric gets the 2 bags that are left over. How many marbles does he get? Okay, so everyone gets 2 bags. For this question, it would be very hard to try to figure out the correct combinations of bags to give everyone. So let's just pick these randomly. Instead of worrying about who gets what bags, we can just count the total number of marbles and the total number of marbles that each person gets. And the ones that aren't done are given to Eric. So in all these we have, the first one is 10 plus 9 plus 8 plus 8 plus 7 and we just add it all the way to plus 1. If we add up 1 to 10, you can get 55. So we have 55 total marbles. And then the total number of marbles each person gets is 15 plus 5 plus 7 plus 9, which is equal to 36. So we have 55 total marbles. And 55 minus 36 is equal to the leftover marbles, which are the ones that Eric gets. Which is equal to 19. So the answer for problem 21 is E, 19. So this problem, don't waste your time. If you can cut corners, then cut corners. Don't waste your time by figuring out who gets which bags of marbles. All you have to do is just count the total number of marbles and subtract it from the ones that the first 4 get, and then the last one goes to the last person. Don't waste your time doing things that aren't necessary. Okay, so now we're on to problem 20. A number is written into every square of a 4x4 table. Mary is looking for the 2x2 table where the sum of the 4 numbers is greatest. How big is this sum? Okay, so we're looking for the greatest sum that is within a 2x2 table, or a 2x2 square, where there are 4 blocks and 2 on each side. Obviously, we would look for the biggest numbers, and the biggest numbers we have are 7, which is here, and 4. We also have some 3s, a 3 here, and a 3 here, but it's best to skip them because 4 and 7 are much larger than 3. So we won't worry about them. And then we can find the 2x2 table that shows all of these. So 1 here and 1 here includes those. So you'd have a square like this. And if you add all these together, you have 4 plus 7 plus 1 plus 1, which is 11 plus 2, which is 13. So your answer for problem 20 would be C. Okay, so these problems were pretty easy. Let's keep going. Do you want to keep going, or do you want me to talk about a math topic? Okay, let's just keep going. Does anyone want to try number 19? If you don't want to, that's okay. You can say it in the chat if you want to, or just say out loud. And then the homework will be as usual, so it'll be the same Google document. You should have that saved. I'll send it again in the WeChat if you need me to. And then I'll say when I update it too. Okay, so it doesn't look like anyone wants to do problem 19. So I'll just do it. So 4 brothers have eaten 11 biscuits altogether. and everyone has eaten at least one biscuit, but all of them have eaten a different number of biscuits. 3 of them ate 9 together, where one of them got 3. How many did the boy who got the most biscuits eat? Alright, so they have eaten 11 total, and 3 of them ate 9, and then 1 ate 3. So we have 11 total. The first 3, let's just say A, B, C, ate 9, which means that D must have eaten 2. So if brother D ate 2, that means that A, B, and C could not have eaten 2. So let's move on to figuring out how many that A, B, and C ate. So A ate 3. So B and C ate 6. And B and C could not have eaten 3 cookies because they're not allowed to eat the same number of cookies, nor could they have eaten 2 cookies because D also ate 2. So the only way we could do it is B ate 1 and C ate 5. So we'll just write this out. So A, B, C, D is equal to A ate 3, B ate 1, C ate 5, and D ate 2. 3, 1, 5, and 2, and the largest number is 5. So our answer for 19 is C. These questions have been very easy. As the years go by, the tests actually get harder and harder because people learn more each year. So, also one more thing. Math Kangaroo has a lot of straightforward questions, which means that the early ones might be very slightly harder than the later ones, because the later ones all you have to do is just fill in things and write out different combinations. Like how number 22, all you had to do, it looks like one of the hardest questions on the test, but all you had to do is just write out a number of different ways that Susie had seen the animals. For number 23, it's even easier. All you have to do is just cross out each petal for when you use them, and then to not stop after one try because it might not be right. 24 is a little tough, but also all you have to do is guess. 21, we used a neat trick where you could just skip the entire part where each person gets 2 bags and just count whichever marbles that Eric gets, the leftover ones that Eric gets. 20, you just have to find the largest numbers. And 19, all you had to do was just write out how many each brother got and use that to figure out what the next brother got. Should we move on to 18? Does anyone want to move on to 18? Actually, we'll go to 15 and then we'll stop. So George starts his training at 5 o'clock in the afternoon. It takes him 5 minutes to get to the bus stop, and the bus journey takes 15. Then he has to walk for 5 minutes to get to the pitch. The bus comes at 6 in the morning and then every 10 minutes. What is the latest possible time he has to leave the house in order for him to be at the pitch on time? Okay, so he has to be there at... Oh, there's a chat. Okay, so we'll continue. Let's just write the times that we could do. So it comes at 6 o'clock in the morning for the first time and then every 10 minutes. Okay. He needs to be there at 5 p.m. which means that the bus stops going at which means that he's picked up by the bus 20 minutes before it starts. So 5 minutes walking and 10 minutes on the bus. So at 4:40, he must be at the bus stop. And then he can leave at which is one of the times that the bus comes, because it comes every 10 minutes and only on the 10 on each 10-minute increment. And then he leaves at 4:35, which is 5 minutes before 4:40. And so we look on here. 4:35 is answer A. So your answer for 18 would be A. Okay. Let's go to 17. And then for 18, the strategy here is just write out your steps. Try not to forget anything. And don't leave anything out. Read this carefully, because if you skip the part where the bus comes every 10 minutes, you might get it wrong, which isn't very good. Okay, so 17, Max builds his construction using some small, equally large cubes. If he looks at it from above, the plan on the right tells the number of cubes in every tower. How big is the sum of the numbers covered by the two hearts? Okay, so we'll just draw some lines to fill in the... Actually, this one you just have to look at the shape. Try to figure out which way the shape is oriented, and because these two over here, the ones that my maps are over, are only one tall, and this column here is one taller than these two, it must be two tall. So the first heart must be 2 equals 2. And then the second heart corresponds to this one, which is slightly covered up behind the tallest one. And you can count 1, 2, 3, 4. And the second one was one shorter than the tallest one, so 4 minus 1 is 3. So second heart is equal to 3. And if you add 2 and 3, you would get 5. So the answer for problem 17 is 5. This one is also incredibly easy. I'm not sure why it was put last, but all you have to do is just take a good look at the sculpture and try not to miscount anything. Once you have that, the answer is very easy to get. Which number must be written to the circle of the question mark so that the calculation is correct? Okay, so this one looks pretty tough. But if you look at each operation, it'll actually be very, very easy. So look at each operation. Here, plus 6. This means that this box plus 6 is equal to this box. This one times 4 is this one. This one minus 15 is the question mark. Question mark plus 4 is this over here. And this one times 0 is this over here. And we all know that anything times 0 is equal to 0, no matter what you put in. 5 times 0 is 0, negative 3 times 0 is 0. So we can just put this as 0. We don't know, we can't put anything else, but we don't know what is over here. We just know that this must be 0. And then we just continue through the loop. This is 6. This is 6 times 4 is 24. And then 24 minus 15 is equal to 9. So we know that the question mark is equal to 9. So our answer for 16 would be B. Okay, is there anything about how much time we have left? Colin, do you see anything about how much time we have left? If not, we'll just keep going. Okay, so Problem 15. David has a stove with 2 hobs on which he wants to prepare 5 different dishes. The dishes need 40, 15, 35, 10, and 45 minutes. He wants to spend as little time in the kitchen as possible, but is only allowed to take them off when they're fully cooked. How long does he need for the preparation? Okay, so he has 2 stoves. And a bunch of dishes that he can put on. So actually, we'll skip this question because this is very easy and I only have 10 minutes left. So I'll just quickly run over these questions. 24, all you had to do again, because just to let you know what different strategies that you would have to use to do these questions. For 24, all you had to do was make educated guesses and find the situation where you need the least guesses, the least possibilities, and then expand from there. 23, all you have to do is just fill in. Also stay organized, or you might overcount or count a pedal less than what you're supposed to do. 22 is similar to 23. Write out all the combinations and do not forget anything. 21, always look for ways to cut corners and save time because you have a lot of questions to do and you don't want to waste time on things that you actually can skip. 20, just look for the largest numbers. Look for what the question asks you to look for. 19, find what is easiest to find and then find everything else from there. 18, just write out the steps. 17, ridiculously easy. Just look closely at the diagram and don't miscount anything. 16 is a little tough. All you have to do is just look at the diagram, figure out what patterns you need to do, and look for what must be guaranteed. What numbers must be guaranteed for you to have something. Okay, so these are all the questions. And then the homework is over here. I don't have the questions ready right now, but I'll announce on the WeChat and also send the link again when I have finished the next questions, the next homework set. Okay, does anyone have any questions? Okay. So, bye-bye everyone. I'll end the meeting now. Bye.